This section of the resource will introduce you to the spirometry equipment and show you how to use it. Apparatus shown being a wet spirometer. Apparatus consists of a light metal triangular shaped wedge inverted into a tank of water which traps a certain volume of air. The apparatus can be calibrated so that the movement of the lid corresponds to a given volume of air contained within the wedge. A spirometer is initially calibrated with a known volume of oxygen in the air tank, with the chart recorder marking a value before and after oxygen is added. Connected to the wedge is a digital thermometer and a counterbalance arm to allow the wedge to be adjusted. A mouthpiece with two wide tubes allows the airways of the subject to be connected to the spirometer in a closed system. Tubes run from the chamber to a mouthpiece and back via a one-way valve. At the front end of the spirometer there is a wheel from which the two flexible tubes protrude. This wheel is used to direct airflow from the subject to either the atmosphere or into the spirometer. Airflow can be adjusted by simply turning the wheel. Breathing in and out through the tubes makes the wedge rise and fall. The volume of air the person inhales and exhales is calculated by the distance the wedge moves. During expiration, the volume of air within the spirometer increases and the wedge rises. Therefore, the pen on the trace goes upwards. During inspiration, the volume of air within the spirometer decreases and the wedge falls. Therefore, the pen on the trace goes downwards. Volume changes are communicated to the computer via a potentiometer that measures the incline of the wedge. The potentiometer converts the incline measurement of the wedge into an electrical signal, which varies in frequency depending on the degree of the incline. Electrical signals are then fed into the PowerLab software that is used to create plots of the data collected so that lung volumes can be measured. To measure vital capacity, use the handle on the airflow wheel to make sure that it is set to subject to spirometer. With the wheel in this position, there should be no resistance as the wedge is raised or lowered. The spirometer can be filled with air by placing one hand on either side of the wedge and carefully and slowly lifting the wedge out of the water until it is approximately 6 litres full, as indicated by the scale pointer on the volume scale. You should ensure that the wedge does not completely come out of the water. Once full, turn the wheel to subject to atmosphere. The spirometer wedge will remain elevated as the air is trapped within the wedge and not forced out by the weight due to the counterbalance bar. Do not try to raise or lower the wedge by hand when the wheel is turned to subject to atmosphere, as the closed valve will force air out around the wedge and cause the water to overflow. Notice if the wheel is left in the subject to spirometer position, the wedge will sink due to the valve being left open. The subject must wear a nose clip for this experiment to ensure a closed respiratory system. Place a clean disposable cardboard mouthpiece inside the plastic mouthpiece area. Next, the subject should form a tight seal with their mouth around the mouthpiece. This ensures that no air escapes as they breathe through the mouthpiece into the atmosphere until they are comfortable breathing in this way. When the subject is comfortable, click the Start button on PowerLab and turn the wheel to the subject to spirometer position. The spirometer wedge should then start to rise and fall in turn with the subject's breathing. Allow the subject to establish a steady rhythm of breathing before continuing further. When the trace is steady, the subject should make a maximal inspiration immediately followed by a maximal expiration. This will show the subject's vital capacity. The inspiration and expiration should not be hurried and must be as complete as possible. Check that the spirometer wedge neither comes out of the water on maximal expiration nor reaches the bottom on maximal inspiration, as this will lead to an underestimation of the subject's vital capacity. Return to a normal rate of breathing after maximal expiration and click Stop on PowerLab. Once finished, turn the wheel to subject to atmosphere. The subject should not be allowed to breathe from the spirometer for more than a few minutes without refilling the wedge with fresh air, as this could cause asphyxiation. You can refill the spirometer with air by turning the wheel to subject to spirometer, gently pushing down the plastic wedge until all the air has been expelled, then carefully lifting the plastic wedge to introduce fresh air back into the spirometer. Repeat this process more than once to fully refresh the air. Measuring forced vital capacity, or FVC, involves repeating the same procedure described for measuring vital capacity, but as inspiration reaches a peak, the subject is to breathe out as fast as possible and continue until the trace produces a plateau. The expiration should be for a minimum of at least 3 seconds. The entire expiration is recorded and the speed, duration and overall shape of the breath are examined. Forced expiratory volume, or FEV, measures the volume of air expelled by the lungs in 1 second. This allows clinical assessment of any changes in resistance to airflow in patients. FEV1 can be measured from forced vital capacity recordings. FEV1 is routinely expressed as a percent of the forced vital capacity. In healthy individuals, the percentage is recommended to be above 70%. FEV1 is abnormally low in patients with obstructive diseases such as asthma and COPD, and can be graded for severity as shown on this chart. Measuring FEV1 can be done by looking at forced vital capacity recordings. Move the marker M to the point of maximal inspiration. This is when the subject is about to breathe out. Move the cursor along the trace towards the top of the forced vital capacity recording until time equals 1 second. Time is shown above the trace. The volume of air expired in 1 second will be calculated by Paralab. Remember that FEV1 value taken is in litres at ATPS. This requires conversion to litres at BTPS using the digital thermometer and conversion chart. The value obtained can then be used to calculate the FEV1 as a percentage of the mean forced vital capacity. Peak expiratory flow rate, or PEFR, measures an individual's maximum speed of expiration in litres per minute by fully inflating the lungs and breathing out as fast as possible into a peak flow meter. The meter has a scale corresponding to litres of air per minute. The faster the airflow, the further the piston inside moves the marker along the scale. The scale and the holes on the end must not be obstructed. To perform, fit a clean cardboard mouthpiece and move the scale marker back to 0. Standing up, breathe in as deeply as possible and close your lips around the mouthpiece to make a seal. Blow as hard and as fast as you can. You do not need to breathe out completely. Measurements are repeated to get an average result. No conversion from ATPS to BTPS is necessary. However, because the measurement is made at high lung volume, it is effort dependent and is influenced more by the resistance of the larger airways. Example is the trachea and primary bronchi rather than by the other smaller airways within the lungs. An abnormal result should therefore be checked by carrying out a more discriminating test, such as FEV1 against forced vital capacity. For more information, see the in-depth section.